Okay, ladies and gentlemen, if I am asked to simplify the square root of 72, 72 is not a perfect square. In other words, it doesn't come out pretty like if it was the square root of 25. So what we need to do here is we need to remember what the perfect squares are, okay? 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, and so on. All right? What I want to try to do is find the largest number from this list that is a factor of 72. In other words, that goes nicely into 72. Well, I believe the largest number from this list is 36. So what we can do is we can write this. We can rewrite 72 as 36 times 2. 36 is a perfect square. It's the largest one that is a factor of 72. We now use the product rule. The product rule tells me we can split this up into a product, into two parts. The square root of 36 is 6, no more radical, and the square root of 2 remains as the square root of 2 because 2 is not a perfect square, so it keeps the radical. All right, let's look down here at the cube root of 81. 81 is not a perfect cube, so we need to find perfect cubes. Now here's how we do that. 2 to the third power is 8. 3 to the third power is 27. 4 to the third power is 64. Okay, that's big enough. Look over here. We're trying to find a number from this list of perfect cubes that goes nicely into 81. And sometimes you need to use your calculator, but you'd find out that 27 divides into 81 3 times. So we rewrite this as the cube root of 81 is 27 times 3. And now what I do is I use the product rule to break this up. This becomes the cube root of 27 multiplied by the cube root of 3. The cube root of 27, what times what times what gives me 27? That would be 3. And the cube root of 3, 3 is not a perfect cube, so it remains under the radical. And it is very important that you put the index with it. Okay? Up here it doesn't matter because the index is a 2, it doesn't have to show. But when the index is a 3, it has to show. How about the fourth root of 64? Well, we need to first of all create our list of perfect fourth powers. 2 to the fourth power is 16. 3 to the fourth power is 81. And so on. You know, the list gets bigger. Well, I think we're good right here because if I look over here, I can see that 16 is the largest number in this list that's going to divide into 64. So 64 can be written as 16 times 4. 16 is good because it's a perfect fourth power. Okay? So we break this into the fourth root of 16 times the fourth root of 4. The fourth root of 16, what times what times what times what gives me 16? That would be 2. And the fourth root of 4 does not come out pretty, so it remains under the radical. So my answer here is 2 times the fourth root of 4.